Step 5 in the 5 steps of hypothesis testing is to make a decision. Remember that the curve of a normal distribution represents relative frequency. If you were to choose a score at random, you have a high probability of choosing a score close to the mean. As scores get farther from the mean, they have decreasing probabilities. When a score is far from the mean, that score has a low probability of being selected at random. We used an alpha level of 0.05 to set a fence that excluded 5% of the scores in the tails. That fence is a critical value. Scores outside of the fence are in the critical region. The critical value sets the critical region. The critical value also goes by other names, depending upon how you are speaking about it. The terms critical value, alpha level, and cutoff score are all referring to the same thing. You ran your statistic in your statistical software. Now you engage your brain, examine the output, and make a decision about what your analysis tells you. If the observed value, the test statistic, is less likely, in other words, farther from the mean, than the critical value, then the difference between the sample and population is statistically significant. You will reject the null hypothesis. The observed value is in the region of rejection. The difference between the sample mean and the population mean was not due to chance. And you assume that the alternative hypothesis is accurate. The difference was due to an effect. Before we begin interpreting, let's put all of the pieces together. We start with our normal curve that represents the distribution of all of the possible sample means. The horizontal line is our x-axis. On the x-axis, we can put our number line. These are population means. The mean of the population is mu equals 7.5. We set a fence to exclude 2.5% of the scores under the normal curve on the left, and another fence to exclude 2.5% of the scores under the normal curve on the right. The critical value to the left is negative 1.96 standard deviations, a cutoff score of 4.95, defined by an alpha of 0.05 or 5% total. The critical value to the right is positive 1.96 standard deviations, a cutoff score of 10.10, defined by an alpha of 0.05 or 5% total. These two critical values represent an alpha equal to 0.05. So the probability of finding a score closer to the mean inside of the fence is greater than the cutoff of 0.05. Alpha is greater than 0.05. The probability of finding a score far from the mean outside of the right fence is less than the cutoff of 0.05. Alpha is less than 0.05. The probability of finding a score far from the mean outside of the left fence is less than the cutoff of 0.05. Alpha is less than 0.05. And because different terms can be used, P equals 0.05, A equals 0.05, and alpha equals 0.05 all represent the same thing. Let us interpret the findings for our baby weight example. Our Siberian sample mean had a value of 11. The observed value of 11 exceeds the right critical value of 10.10. Therefore, it is statistically significant, and the probability of randomly selecting a sample with this mean is less than 0.05. We will reject the null hypothesis that says there is no difference. We will conclude that there is a difference. We will say that the sample mean from Siberia is statistically significantly different than the population mean of 7.5. To summarize, our Siberian sample mean was 11. The world population mean was 7.5. And the probability of randomly selecting a sample with a mean of 11 by chance is less than 0.05. Less than 5 times out of 100 would we select a sample with a mean of 11 only by chance, if the sample and population were really the same. Well, let's say that we studied another country, and we found that the average weight of the babies born in that country was 4.23 pounds. The observed value of 4.23 exceeds the left critical value of 4.95. Therefore, it is statistically significant, and the probability of randomly selecting a sample with this mean by chance is less than 0.05. And now we sample a third country. This country has an average baby weight of 6.34 pounds. The observed value of 6.34 is between the two critical values. It does not exceed either critical value. Therefore, it is not statistically significant, and the probability of pulling a sample at random with a value of 6.34 is greater than 0.05. This is an expected mean that we might randomly select if the sample is drawn from a population with a mean of 7.5.